So in this example, we're going to look at this problem. A social psychologist studying mass communication randomly assigned 82 volunteers to one of two experimental groups. Group 1, with 61 individuals, gets news only from TV for a month, and Group 2 gets news only from internet for a month. Afterwards, they're all going to be given a test on several political topics. Use the information below when alpha equals 0.05 to test the hypothesis that the knowledge of political topics would be different between the two groups. And then we're given some data. We're given the mean for the TV-only group and the EVAR for the TV-only group, and the same information for the internet-only group. And we're going to begin this problem by doing the mathematics, and then we're going to parse out the problem. So let's begin by organizing the workspace. Let's first put condition 1 on one side. And let's name it TV only. On the other side, let's put condition 2, internet only. And so from here, we can organize our data, and you'll notice we aren't starting with raw data this time. We actually had someone helpfully do the calculations for us to get us started. So we are going to need to start with the same basic information. We're going to have to start with N for sample 1 and DF, the same things we've been getting all along. M for sample 1, SS for sample 1, EVAR for sample 1. And we'll need the same for sample 2, N2, DF2, M2, SS2, and EVAR2. And so let's go ahead and get the pertinent information. N1 is stated in the problem as 61. So DF1 is N1 minus 1 equals 60. M1 is stated in the problem as 24. Variance, or EVAR, is stated in the problem as 4. And because we know EVAR, we don't need SS. We need SS when we have raw data, but for now, we've already gone beyond it. N2 is stated in the problem as 21. So DF2 equals 20. M2 is stated as 26. SS2 is not stated because we have EVAR, which is stated as 6, so we don't need SS2. From here, we continue on to these unique aspects of the independent samples t-test. And so we need to take advantage of information from both problems to get at the answer to this. So we're going to use our EVAR to calculate what we call the pooled variance so that we get the most accurate variance possible. And the variance pooled equals the proportion of degrees of freedom from the first sample, proportion, and I'll show you this in a moment, times EVAR1 plus proportion 2 times EVAR2. And you'll be wondering what this proportion is. And proportion is just the percent of degrees of freedom belonging to each condition. So proportion 1 equals degrees of freedom 1 out of degrees of freedom total. And you already learned that DF total equals DF1 plus DF2. And so in this case, that would be 60 plus 20 equals 80. And so proportion for sample 1 is going to be 60 divided by 80, which equals 0.75 or 75%. We can do the same for proportion 2. Proportion 2 equals 20 divided by 80, which equals 0.25 or 25%. So what this means is we're going to calculate var pooled by taking 25% of this 6 and adding to it 75% of this 4. So let's go ahead and do the math. Equals 0.75 times 4 plus 0.25 times 6. And this equals a total of, whoops, let me pull this aside. And this equals a total of 4.5. And so now what we've done is we've taken these two pieces of information and used them to get various pooled, and we've done the same here. So now we can take this variance pooled and use it to figure out varm for sample 1 and sample 2. So varm 1 equals var pooled divided by n. And you'll notice this is the same formula that we used when we created varm before. We used evar divided by n. We're doing the same thing, but we're using var pooled. And we'll do the same here. Varm 2 equals var pooled divided by n2. So let's calculate these out. That equals 4.5 divided by 61. This equals 4.5 divided by 21. And in the latter case, this will equal 0.2143, 0.2143. And in the former case, this equals 0.0738. And so with these two varm ones, we are done with the data from these samples, at least in terms of figuring out what spread will be. So we go from here to figure out varm for the comparison distribution. And in fact, let's label this. Everything we're doing in the center here is what we're doing to understand the comparison distribution. And basically, we're doing this to figure out spread. So varm is the sum of varm 1 and varm 2, which in this case equals 0.0738 plus 0.2143, which equals 0.2881. And then we do the same thing we've done before. We use the square root of varm to get SM, which is going to be our measure of spread. SM is going to be the square root of varm, just as it was before, and that equals 0.5367. And we have one more calculation to do, and I'm just going to do it right away so that we can then get into parsing the problem and completing this test. We need to have the t-score. And for this test, the t-score is M1 minus M2 divided by SM. And so if we plug in those data, we come up with equals mean 1, which is 24, minus mean 2, which is 26, divided by 0.5367. And that equals minus 3.73. And so right here, these two pieces of information, SM, will be used in step 2 for spread. And T will be used in step 4 when we calculate the t-score. So let's go ahead and parse this problem. So reading the problem again, we're looking at people who are assigned to listen to the news only from TV for a month, comparing those who get the news only from the internet for a month, and we're measuring knowledge of political topics. So let's go ahead and parse the problem. So step 1, parse, and population 1 equals people getting news from TV only. Population 2, people getting news from internet only. The DV is knowledge of political topics. The tails, it simply states that they're different. So we know that this is a two-tailed test. And we'll just write our hypotheses in the brief form. H1 is mu1 is not equal to mu2. That's what it looks like in a two-tailed test. And HO, mu1 equals mu2. And so let's go ahead and get the rest of our steps. Step 2, the comparison distribution. And we know that it is going to be a t-test. And what we're actually comparing, I'll put it in parentheses, of the difference between means. So it says if we got a whole bunch of random samples from this population, we calculated the mean for each and subtracted them, and we ended up with a distribution that's normally distributed with a center mu equals 0, and a spread SM equals, and here's where we pull this number in, 0.5367. In step 3, we determine the cutoff point, and we use our calculator to do this. And so we're going to use alpha equals 0.05. We're going to use two-tailed, and we're going to use our DF total, which equals 60 plus 20, which equals 80. And so let's go ahead and get our calculator out. And this is not it, so let's go to it. So I always have it bookmarked under our course number. So here is our T critical value calculator. We're looking at a 0.05 significance level. 0.05, see if we can get this to click in there for me. And we had 80 degrees of freedom. And so let's go ahead and calculate. And we discover that the two-tailed test has a cutoff of plus or minus 1.99. So let's record that. T alpha equals 1.99, and that is plus or minus in this two-tailed test. Going on to step 4. We are going to calculate the sample t-score. And we've already done so, but let's write the formula once again. It is M1 minus M2 divided by SM, which equals in this case minus 3.73. We can plot out our distribution to determine significance, and we'll do so over here. Our cutoff points were TA equals 1.99, and on the other tail, TA equals minus 1.99, and the shaded region will be either tail. The fail zone is in the center, and our sample t-score is way out here somewhere, minus 3.73. And so because it is in the reject region, not the fail region, our conclusion, our decision needs to be reject HO. And we conclude that people who get news only from TV have lower political knowledge scores than people who get news only from internet. And the statistic T with individuals' degrees of freedom 80 equals minus 3.73. And we tested at the 0.05 significance level. And that is the end of problem 1.